Hi, class. So today we're going to be uh, doing a little bit of fractions. We're going to talk about adding and subtracting fractions today. So today our objective is going to be that students will be able to understand the meaning of fractions and apply that knowledge in different strategies in order to add and subtract fractions. So we're going to look at how what a fraction is, what each part of it means, and how we can use that information to be able to add and subtract them. All right. So what are fractions? Fractions are basically just like a piece of something. So here we have a pizza. And so when we get a pizza, it's usually cut into 8 slices. So we have fractions of a pizza. Each piece of the pizza is a fraction of the whole pizza. So fractions are just like pieces of things, and using pizza is a great analogy for understanding fractions, because it's something that is always the same, and I hope all of us have had pizza and know what it looks like and what a piece looks like. So it's just a good representation of that. All right, so fractions have 2 pieces to them. They have a numerator and a denominator. So I'm going to start talking about the denominator first, which is this number on the bottom here. The denominator is how many total pieces that you're dealing with. So for example, in our pizza scenario, we cut our pizza into 8 pieces. So we would have 8 as our denominator, because that's the total amount of pieces that makes the whole pizza. And then, so our numerator is actually how many pieces we're looking at. So if I want to eat 1 slice of pizza, then I'm eating 1/8 of the pizza, because I have 1 out of the 8 pieces of the pizza. So that's what that means. We look at it as how many pieces we're looking at out of the total number of pieces. So if we're eating 1 slice of pizza, we're eating 1 piece out of 8 pieces. All right. Does that make sense to everybody? All right. And then now I'm going to just show you a few methods on how we can add and subtract fractions and visually see through manipulatives how fractions are the same, how fractions can look the same, how fractions can be added and subtracted and manipulated. So I'm going to first start with fraction circles, which this works perfectly with our pizza scenario, because we can cut this circle up into as many pieces as we need for our problems. So I'm going to start with this whole pizza, and we're just going to look at some pieces to just compare. So here we have 1/2 of a pizza, and we can see that this is 1/2 because it takes up half of the circle. So here we have one of the halves, and we know that 2 of these pieces makes the whole circle. So we know that 2 has to be on the bottom. That is our denominator, because 2 pieces make this circle whole. And so if we wanted to look at just one of these circles, or one of these halves, then we would just have we would just have a 1 in our numerator, because we're only looking at 1/2 of the circle. All right, does that make sense, everybody? I can show you again with thirds, just so that we're all on the same page. So if I were to have thirds, this is me breaking up this big circle into 3 pieces. And we can visually see that if I was to connect these thirds together, that we would make a whole circle. See, does that make sense? So that's why we have thirds. That's why there's a 3 on the bottom, because we cut it up into 3 pieces. And then now, since this made a whole circle, we would just have a 3 on the top. But if we wanted to look at, say, just 2 of these, well, now we have 2 pieces that we're looking at. So we're going to actually write a 2 on the top. That's what this means. We have 2 pieces out of 3 total possible pieces that we could have. So that means this blank piece would be a third of the pizza, just like the rest of this is 2/3 of the pizza. All right, does that make sense? All right. So now let's just go through some practice problems just to see what, well, actually, no, let's talk about a least common denominator. Because when we're adding and subtracting fractions, we actually can't add and subtract fractions with different denominators. So just for an example, if I had 1/2 plus 1/3, which would be 1/2 plus 1/3, I can't really add those together because I can put them together, but I still don't know how many I have here. Like, I don't know what number that is or what fraction that is because they're 2 different things. If I were to add it across like this, say 2/5, you can see here that if I were to take 2/5, 2/5 does not equal all of this space. So visually seeing that we're missing a good portion of what we're looking at. So we know that 2/5 can't be it. So this is where we come in with a least common denominator. And a least common denominator is pretty much, I'm sorry, I'm trying to erase this and I keep doing the wrong thing. A least common denominator is basically us trying to find a number on the bottom here where 2 and 3 is our denominator. That's the same, that they both can go into. So for example, we can go through the multiples of 2 and 3s, our times table. So if I were to write 2 and 3 and just go over like what the multiples of 2. So if I was to do 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. And I'm just going to stop there because I'm running out of room and I think I have enough numbers now so I can look further, or so I can go to the next number. So now we're going to go to the 3 and do the 3 times table. So 3 times 1 is 3 and 3 times 2 is 6. And now see, this is where the least common denominator is. So the key word here is common. That is the thing that both numbers can, that's a number that both numbers can multiply into. That is the smallest. So here we have 6. They both have 6 in common. So that means that 6 needs to be in our denominator. We know for the future that 6 has to be on the bottom for both of these numbers. So we'll end up with an addition problem where 6 is on the bottom for both numbers. Now, we can look at this multiple ways. We can start with the manipulatives. So we're going to start with here. So we know that 6 has to be on the bottom, our denominator. So we're going to take some 6 pieces and we're just going to fill up our current circles. So if I was to fill up our 1/2, I can fit in 3 of these sixths. And if I was to take our third, I can fill in about, sorry, hold on. I can fill in about 2 of these sixths. So looking at this visually, we can just add across. So if 6 is our denominator, we can just count how many on the top we have in total. So if we have, so if 1/2 is equal to 1, 2, 3 sixths, and our 1/3 is equal to 1, 2 sixths. And then when we add and subtract fractions, our denominator is always the same because we are never changing the total amount of pieces that we're using when we're adding and subtracting. All right. And then we could get 5. So because we add the top, because we have 1, 2, 3, 4, 5 of these sixths. All right. And then we have 5, 6 as our answer that way. Now we also can look at doing this with just numbers. So we can look at it as a different way. So if we were to take our 1/2, for example, we have to get 1/2 to be equal. We have to get our denominator to be 6. So what can we multiply 2 to get 6? Exactly, 3. So if we were to multiply by 3 here, we know that we would have 6 on the bottom of our fraction. Now, what do we do to the top? Because we know that 1/2 is not equal to 1/6 because they're different sizes. Once we fit 3/6 here into our 1/2. So we know that that can't stay the same. It has to be changed. So what we want to do is we want to multiply the 1 by 3 as well, because we could fit 1, 2, 3 of our sixths inside of our 1/2. So we would multiply our 1 by 3 as well. So then we have 3/6. And we can always know that whatever we're multiplying our denominator by is what we're going to multiply our numerator by. It's always going to be the same as the top and bottom are being multiplied by the same number. So now let's try with our 1/3. Our 1/3 is going to work exactly the same. What can we multiply 3 by to get 6? Exactly, 2. So if we wanted to multiply by 2, let's try and look at it like we did before. If we're multiplying the bottom by 2, what do we have to multiply the top 2 by to get this an equivalent fraction? We did the exact same thing here. Exactly, 2. So we're just going to multiply across like we did on the first one. We multiply 1 times 2 is 2, and 3 times 2 is 6. And then we just simply add those two like we did over here. And these circles are the exact visual of everything I just did here. We had 1, 2, 3 multiplied by 3, and 1, 2, and multiplied by 2. So that is what we do for circles. Now we also have another approach that we can do. If you don't like the circles, I just have to erase this because there's no like clear button for this. Now we can also look at fraction bars in a second, which fraction bars are pretty much work exactly the same as our circles, except they're a little bit easier to connect. They don't overlap. They build below each other. So when we have, so we can visually see that we have one whole bar, and that two of these, and that if we wanted to cut this in half, we would have 2 pieces, 2 halves that both make up that whole. So we have a line here, and the same thing works if we were to look at thirds, and if we were to look at fourths. And we can already see that, like just looking at this, we can see that this line for the fourths cuts the 1/2 directly in half. So these can just offer a bunch of different visual things already there. So let's try working with that. I'm not going to go over the, well, actually I can. So I'm going to take an equation of 1/3 plus 1/4. And so when we have our fraction bars, we just want to take our pieces of 1/3. So here with our fraction bars on this program, we can actually shrink our square down by using this arrow here. And we just want to take our 1/3 and then our 1/4 and shrink this down because we only have one of these pieces. So what we can do here with our blocks, I'm going to go over how we do it with our blocks, and then I'll go over how we can do it with our number as well. So what I'm going to do is I'm just going to take our 1 whole, and I'm going to match up these together just to see about how much it looks like comparison. So just looking at it, it looks like it's a little bit over half of the bar. So I just know realistically it cannot be 1/2 because it is more than this bar. Now what I want to do is I want to look for the least common denominator. So what I'm going to do is I'm just going to go through the multiples of 3 and the multiples of 4. So whenever we're looking for the least common denominator, we only want to do the times tables of our bottom numbers. So that's what we're trying to make the same. So we do 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. I'm just going to stop there because I have a good bit of numbers. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So I'm going to stop here. And why am I going to stop here? Because they both have 12 in common. So I know that the denominators need to be 12 when I'm adding them. So what I'm going to do now with my blocks is I'm going to take 12s out to use to look at how many goes into each. So what I'm going to just do first is I'm going to line up my 12s with my 1/3, and I'm just going to shrink it till they're the same, because I know that they will be the same because they have multiples of it. So I can see that I fit 1, 2, 3, 4 of these 12ths in there. So this would be the same as 4 12ths. And then I'm just going to do that again with my 4th. And then I'm just going to shrink it down to the same. And now I can just count how many I have, which I have 1, 2, 3 12ths. And now all I have to do is just add those together because they're the exact same as 1/3 and 1/4. And then remember, we keep our denominator the same because that's just how many pieces that this whole was cut up into. So we have 12 on the bottom all the time. And then we add 4 plus 3, which is 7. So I know that 7 12ths is my answer. Now, if I wanted to look at this with the numbers, then I would do a little bit of multiplication as well, which, so I'm going to do over here. So if I want to look at 1/3, what can I multiply by 3 to get 12 on the bottom? So I know that I have to have 12 right here. Exactly, 4. Now, because I can, now for the numerator, like I said before, we're multiplying the top by the same number as we're multiplying the bottom. But I can also see that from these blocks, I was able to fit 4 of these 12ths into my 1/3. So I know that I have to multiply 1 by 4 too, because that's how many I could fit inside of this, inside of that bigger block. So now I know I have 4 12ths that way. And then the same thing with 3, sorry, not 3. And the same thing with 1/4. If I want to multiply something by 4 to get 12, I know that 12 has to be on the bottom here. So what would I multiply by 4? Right, 3. So, and I know that I have to multiply the top by 3 because I was able to fit 1, 2, 3 12ths inside of my 1/4, and because I have to multiply the top and the bottom by the same number. All right, so now I have 1 times 3 is 3. And then I just simply add across, add the 2 top numbers like I did here, and our answer becomes 7 12ths. All right, does that make sense to everybody? Okay, so now we're going to move into our whiteboard practice. So I'm going to end up presenting you a lesson, or I'm going to end up presenting you a problem, and you guys can use your manipulatives or multiplication or however you guys want to show your work. And so here we go.